Hello all. I'll be covering cost, scaling, and best practices of Snowflake Openflow on Snowflake deployments, which is also called as Snowpark Container Services. SPCS today is on AWS and Azure commercial regions. Let us go over the details of cost and how it can scale, the Openflow can scale, and what are some best practices when you are budgeting of Openflow. As we discussed in my previous videos, what is Snowflake Openflow? It is a managed Apache NiFi on Snowflake environment. You can use Openflow to move the data from any source to any destination. And you can build a lot of custom flows using Openflow. The custom flows can be built on Apache NiFi. But the important aspect of Openflow is its connectors. There are several connectors that support reading the data from different disparate sources and ingesting into Snowflake or pushing the data outside of Snowflake, such as Kafka connectors or Oracle, SAP, SaaS connectors, Salesforce, and there are CDC connectors, there are IoT log connectors, and there are varieties of connectors that you can see on Snowflake documentation. So the main aspects of Openflow is to move the data from one place to another place. You have two different types of deployments that are supported. One is Snowpark Container Services. The other one is a bring your own cloud. So Snowpark Container Services means your Openflow and both data plane and control plane runs on Snowflake, where the connection is established outbound to Snowflake, which means when a connection is initiated in Snowflake, it goes into your cloud or on-prem network. It pulls the data and process inside Snowflake. Whereas in BYOC deployment, the deployment of data plane runs in your own cloud, which means the data doesn't um, uh, the data will be processed within same cloud environment and it will be pushed to Snowflake environment. So it is inbound to Snowflake. So how you consider which one to choose is based on your use case. Typically, if you want to keep your data within your compute cloud or your private public cloud, and you want to have your security guardrails within your own cloud, you bring your own cloud. And if you want to use managed Snowpark container services within Snowflake, which is an outbound connection from Snowflake to your cloud, use SPCS. So right now, it is only available on AWS and Azure. I think there is a documentation. Uh, there is no documentation related to GCP yet. Let us see. The billing is per second with a 5-minute minimum for SPCS compute. Typically, part of your Snowflake documentation, you would say SPCS compute is within the billing per second with a 5-minute minimum to start with. And we can clearly see the difference between SPCS and BYOC in this slide. And on the left side, you see SPCS, which is also called a Snowflake deployment. On the right side, you call it as bring your own cloud. So inside, so SPCS, so your processes data is inside Snowflake on Snowpark Container Services. Whereas, so where it runs is inside your own VPC on AWS is BYOC. I think here there is a slight mistake of Azure. Uh, Currently Snowflake support only BYOC on AWS. Compute billing. So you have 5-minute minimum billing in Openflow in SPCS environment, whereas in Bring Your Own Cloud, it is based on your cloud provider uh, credit consumption and the VCP. I believe it is 1 minute minimum. Infrastructure cost. All the bills, all on Snowflake bill, so no separate cloud cost. Whereas in BYOC, the cost is split between Snowflake and your cloud provider, because majority of your infrastructure runs in your cloud, but there is some management uh, activity that needs to be done by Snowflake, that the cost involved, it's a cost split between both AWS and Snowflake. Management overhead, there is zero ops if you are running your pipelines or Openflow environment on Snowflake, whereas customer has to manage their own VPC nodes and networking in BYOC. Data residency is with the data is processed within Snowflake environment in SPCS. Data stays in your own VPC, that is fully residency control in BYOC. Idle cost. So the management pool runs 24/7 even at zero runtimes in SPCS, and there is no Openflow cost at zero vCPUs in BYOC, and cloud infrastructure still runs and it will be built for the infrastructure that is running. In billing view, we can go typically check some account views. Here I'll have to double check on Openflow compute underscore Snowflake or BYOC if they are available at this moment. But typically you get this billing view from your metering history tables. So typically SPCS is best for simplicity and Snowflake native workloads. You want to use reverse ETL. But if you have compliance data or you want to be more focused on data locality or complex VPC topologies, BYOC is a better choice. You can also have in the same account, you can have both BYOC as well as SPCS, and you can segregate the workloads based on your compliance and how you want your data to be processed. Let us see the cost components. What are different components involved? Part of Openflow offering from Snowflake. The first one is management services compute. So when you have an Openflow up and running, a management service should always continues to be up and running. It runs 24/7 as long as the deployment that you created is active. It uses a CPU family of x64 underscore s instance. The costs accrue even with zero runtimes running. When you create a deployment, it'll start a management service that continuously run until you delete that deployment. The second one is runtime compute pools. So you will assign typically a certain number of nodes to a runtime, and it is based on whether you create a small, medium, or large runtime. And you can also have an auto scaling starting from minimum one node to 50 nodes. So the runtime compute pools, uh, so there is cost involved on the runtime compute pools in Openflow. There are other costs like standard storage cost for data returned to the Snowflake, and then Snowpipe streaming under the hood. It is also costing about 0.0037 credits per GB. That was as of December 2025. And you would also see cloud service layer. If your cloud services layer usage is less than 10% of your compute usage, there is no cost involved. But otherwise, there is cost involved if it is beyond 10% of your compute usage. So these are several components that are involved part of Openflow cost consideration. Mapping runtimes to Snowflake compute pools. So the first one here, it says management pool. You can also just in Snowflake terminology, we call Openflow control pool 0, and it'll always fall under small CPU x64 instance family. It runs on one single node. runs 24 by 7 as long as the deployment is up and running, right? So the next one is a small node. If you are creating a runtime on a small node, typically one runtime pod per node, and it can scale max up to 2 nodes in small instance family. Typically, you use small node pool for dev test or low volume task connectors. And then the scaling behavior, it will always start with scales one node per additional small runtime. Let us see the medium runtime size. So one runtime per pod per node, and it can go up to a maximum of 4 nodes. So if you want to scale beyond 4 nodes, you have to create a second runtime for medium. So the standard production workloads, typically most of the connectors, the CDC connectors use the medium runtime, and also some streaming services like Kafka. So it'll fall under CPU x64 SL, scales when CPU demands and exceeds node capacity. You can have a minimum of 1 node and a maximum of 4 nodes. If you want more, you can create multiple runtimes. In the large runtime, there could be multiple runtimes per pods, runtime pods per node, and max nodes, it can go up to 10 nodes, and there are 4 instances per 10 nodes. Typically, we use large runtimes for high volume or complex transformation custom pipelines or some of the CDC sources. And typically Oracle, SQL Server, SAP, and Kinesis streaming. And the scaling behavior is 10 runtime nodes, and then it can have 4 CPU x64s L instances. So in a pool, it can go up to 50 nodes, but in a runtime, it can go up to 10 nodes. So it is very important to understand how many nodes that can be scaled in a runtime. If you want to have more than one runtime, you can split that up. After 10, you can uh, go back and create one more large runtime, and you can have multiple custom flows within that. So with that, we have covered mapping runtimes to Snowflake compute pools. As a compute pool, there are small, medium, and large compute pools, and how you can map that to the runtimes that you are going to create, and how many min and max nodes that you can assign per runtime. And based on the use case, you can create multiple runtimes in a deployment. Compute pool scaling. So we discussed in previous slide, if it is a small runtime, it can have it can start with 1, but you can scale up to 2. So if you go to 3, the cost will change, which means it can go to a new node, right? So a small runtime uh, can have maximum of 2 nodes, and so if you want to increase more than 1 node for a small runtime, more than 2 nodes, it's gonna provision another node, and it will keep it to the same the small runtime. Typically use it for dev low volume pipelines. And the medium, so if your medium runtime is created, you can have the node pool that can go from 1 to 4 pods underneath the uses. But if you want to have 5 nodes per medium runtime, it'll provision one more node, right? So in the CPU family of x64 underscore s, the typical standard production workloads, the charge will be uh, changing if you want to increase more, because it can provision a new node and tag it to the runtime. And for the large nodes, you can scale it up to 10 nodes, but beyond that, it needs to provision new nodes. So a pool can have multiple nodes, but if you want to have more nodes for a particular runtime, it has to provision new node within a pool. So in a small pool, if you wanted to have an extra node, it's going to provision extra node, but it might live in, like, let's say if two pods are running within same node, it can. But if I want three pods, it will provision another node and it can just replicate the increase the replicas. Auto scaling rules scales up based on the CPU consumption up to max node setting per runtime, and then scales down to 0 nodes after 10 minutes if the runtime is suspended. And max pool size, a pool can have 50 nodes, minimum configured at 0 for cost savings. And the billing is per second with 5-minute minimum, no charge at 0 nodes. Consumption examples from Snowflake docs. A deployment is created and no runtimes will be charged only for the control pool that is currently running. You'll see one node that is running on CPU x64s family. In scenario B, you would see one small runtime, min and max two nodes, which means there are two nodes running for 1 hour, and the control pool will be using one CPU and runtime pool will be using one CPU. So you'll be charged for two CPU x64s. In scenario C, two small runtimes plus one large runtime for 1 hour. The way it goes is it will need a control plane or a control pool that is running on CPU x64s. And then you have a small runtime that uses the two nodes because you are creating two small runtimes. And then one large runtime, it uses um, four. One large runtime uses four nodes with 4 CPU x64L. So you'll be charged for three small compute pool sizing plus four CPU x64L instance hours. And what are some best practices? How do you tackle like overspending or just spending in conservative way, right? So if you are not using your runtime, it is better to suspend those runtimes. Otherwise, the runtime, if it continues to run, it will continue to use the compute pool, right? When you suspend, it goes down, the pool goes down to zero node size. The second one is right size the runtime. If you have a lighter workload, use a smaller one, typically for dev and test. But if you are using a complex workloads, use medium and large. Start with medium and look at horizontal scaling. And if you think your CPU and memory are going beyond threshold limits based on your observability alerts, try to go use a different medium runtime or use large for that workload. Watch management services cost. Control pool runs 24/7 regardless of runtime activity, and we should always factor that particular cost into the budget from day one. And monitor via account usage views. There are usage views metering daily history. It will track the cumulative value in a day, and there is also another table called metering history that will track hourly usage. And if you provide service type equals to Openflow compute Snowflake, and that will give only Openflow costs. Minimize telemetry overhead. So telemetry is built at 0.02 credits per GB, and it is ideal to enable telemetry table for Openflow because you want that observability. And tune log verbosity introduction, avoid debug level logging at scale, otherwise it will take the telemetry table, the events table gets heavy, and there is charge involved for storage as well. And set the max node limits carefully. When you are scaling up, it can go up to 50 nodes max, right? But you want to limit that, otherwise for some workloads, because you have available nodes in the pool, it can go all the way up to 50 nodes. So it is important. Your max node, like how many nodes you want to horizontally scale, you have to set it appropriately. Monitoring your OpenFlow costs. There are two views: metering daily history and metering history. And one is by the credit consumption by the day, and one the credit consumption by hour it will display. So you have a query here, sample query, where the service type equals to OpenFlow compute Snowflake, and it is grouped by service type, usage date, and order by, and you are hitting metering underscore history. That will give uh, credit by start time, and it will give more granular level of those the the, the credits used for OpenFlow. The key takeaways of this particular session is your management pool runs 24 by 7, so there is cost involved even though there are no active runtimes. And then runtime pools can scale to 0. So if you suspend a runtime that is not used, so there is no charge involved for that runtime. And there is a 5-minute minimum billing pricing for the OpenFlow, and CPU based auto scaling. It can scale up to 50 nodes, but we have to be careful when you set up your horizontal scaling max limits. Monitor the usage using metering daily history to track and alert on spend. You want to see like, hey, if it is crossing beyond your budget in a day, in a month, or in a week, you need to have those alerts. So it is important to set some alerts by metering daily history account usage view. And the pricing model is fixed credits per vCPU, easy to budget and forecast. So it is by the vCPU. To elaborate more on this, let's say small has 2 vCPU, one per one node, and it'll cost by node. And but if you want to have a third CPU, it has to provision another node. So there is fixed cost credit per vCPU, it says. And uh, and so when you observe carefully, if there are two vCPUs running in small node, you'll be charged same. But when you want to have a third CPU, it might have to provision a new nodes. That is when the cost goes to uh, spending for two nodes. So these are some important aspects of the cost involved in OpenFlow, and then how you budget it, and what are some best practices and some of the key takeaways that we discussed.